Welcome to all. So today we'll discuss on radiation injuries. Understand the fact that the radiation injuries could be either accidental or intentional. Accidental exposures can occur during transport, storage, or working with radioactive materials or with errors in dosing during radiotherapy. Most of the civilian incidents that is documented here involve industrial exposures from sealed radiation resources. So all these things could be just an accidental exposures, which is relatively more common. But even in this kind of accidental exposures, the number of casualties is going to be relatively less. But intentional exposures are called as dirty bombs that combine radioactive materials with conventional explosives. These are particularly designed to create a lot of casualties that can outrage the handling capacity of that particular country or the particular area under study. So what are the fundamentals of radiation physics? Understand that radiation energy includes the entire electromagnetic spectrum. But ionization happens only at this level where you get your X-rays, gamma cosmic rays, and your alpha, beta, gamma rays. Okay, so we see this ionizing radiations in detail. So what do you mean by ionizing radiation? Ionizing radiation contains enough energy to remove electron from an atom, generating charged particles. Source of ionizing radiation include alpha particles, beta particles, neutrons, and energy waves, including the radiograph and the gamma rays. So we'll see these particles in detail. Alpha particles. Alpha particles are relatively larger in size, that is 2 protons and 2 neutrons, resulting in a limited travel potential and thus preventing penetration of the skin. Shielding is easy, accomplished with just a piece of paper, and pathology only develops through inhalational ingestion or absorption. Okay, its detection can be challenging since a special Geiger counter attachment is required. So it's going to be a very larger size particle, so the travel speed and the travel distance is going to be very less. It can be easily stopped by just a piece of paper. Okay, this is going to be alpha particles. What is beta particles? Beta particles are much smaller. They are just single electron. Thus, they have greater ability to travel and penetrate tissues. It is a significant hazard if internally deposited, because even if it's exposed externally, it can penetrate the tissues very deeply. So what if it's ingested and it's already inside the patient's body? It's going to cause significant hazard. It is a common exposure since most radioisotopes decay by beta radiation followed by gamma emission. Positrons. Positrons are positively charged beta particles emitted from atomic nuclei. They are the antiparticles of the electron, and interaction with electrons lead to generation of highly energetic photons requiring shielding with lead, steel, or even concrete. So positron sources are commonly used in medicine. Okay, I hope you remember PET-CT, PET, right? Positron emission topography. Neutrons. Neutrons are uncharged particles that are able to generate radiation by altering the atomic nuclear proton to electron ratio. These particles are capable of traveling larger distance because it's usually weightless. Thus, shielding requires the use of helium, water, paraffin, etc. Exposures are rare and usually limited to nuclear fallouts, research, industry, and weapons manufacturing. Gamma rays and radiographs. Gamma rays and radiographs are able to travel meters in air and can penetrate centimeters in human tissue itself. So shielding materials must be very dense, like concrete or lead. Individuals exposed to high doses are at high risk of developing acute radiation syndrome. Even if it's exposed externally, it can cause significant damage. What if the patient has consumed it internally? It's going to cause devastating injuries. So this is an expression that you can see that alpha is very big particles. It can be easily stopped just by a piece of paper or by your hand. A beta particles relatively can travel even more farther and can damage your tissues, and gamma particle travels the fastest, and even aluminum is not able to stop it. Okay, it might require even more stronger, a thicker surface like a lead to stop it. So in short, the types of radiations are alpha with a charge of +2, which can penetrate few centimeters in air, can be shielded with paper, keratin layer of skin itself is enough, and hazard is internal contamination only, requires special detection devices like Geiger counter, and sources heavy radioisotopes like plutonium, uranium, and radon. Beta particles, their charge is -1. Their penetration is around 8 mm into the skin. It can be easily sheared by clothing itself because all our clothing is more than 8 mm, right? And hazardous external skin maybe, and internal contamination is going to be hazardous. Most radioisotopes decay by beta following by gamma emissions. Positron, the charge is +1 and similar penetration, so needs shielding with lead, steel, or concrete. Interacts with electrons, releases photons for energy. That is the reason it requires more amount of shielding than the beta particles. This is usually used in the medical traces. Neutron, the charge is relatively 0. Penetration is variable, depends upon the electron-proton ratio in that particular nuclei. Material with high hydrogen content should be used as a shield, and hazardous, it can cause whole body irradiation. Sources, nuclear power plants, particle accelerators, weapons assembly plants. Gamma radiograph, the charge is 0. It can penetrate several centimeters in tissues. It is usually shielded by concrete or lead. It can cause whole body irradiation. And remember, most of the isotopes decay by beta followed by gamma emissions. This is the gamma one.